Hey everyone, I hope you're having a nice spring break. I wanted to go over one topic while you're away. It's called L'Hopital's rule. And just as a quick review for limits, you'll see in 1a, we're taking the limit as x goes to 3 of x plus 2 over x squared minus 4. So for some limits like this one, all you need to do is plug in the value that x goes to. So here we have 3 plus 2 over 9 minus 4, and our answer is 5 over 5, or 1. Those are the nice limits. Those ones, they work out really well. For 1b, if we take a look at this one, if we plug in -1, let's see what happens. We get 2 times 1 minus 2 over -1 plus 1. And we get 0 over 0. And if you remember, we call that the indeterminate form. Indeterminate form. So indeterminate form is when it's 0 over 0 or infinity over infinity or negative infinity over negative infinity. And what we need to do here is we need to manipulate the equation a little bit. So if we look at our numerator, we can factor out a 2 and we get x squared, 2 times x squared minus 1 over x plus 1. And we can factor that further so that it's the limit as x approaches -1, 2 times x plus 1 times x minus 1, because that's a difference of squares, over x plus 1. And you'll see that the x plus 1's cancel out. And from there, we can plug in -1, and our answer is 2 times -2, which is equal to -4. So that's the other type of limit that we saw earlier this year. The third type of limit, if we look at C, this is as it's going to infinity. Well, if it's going to infinity, remember, the thing that we're looking at is the largest degree in the numerator and the largest degree in the denominator. Because they both have the same degree, we call this a balanced equation. And because it's balanced, we only need to look at the coefficients of the largest degree. So we get 3 over 2 as our answer. Another nice, easy one to do. But now we look at D, and when we plug 0 in here, we get, let's see, e to the 0th is 1 minus 1, which is 0, and 0 in the denominator. And this is the indeterminate form. We've got to ask ourselves, well, we can't factor the top because it's not a difference of squares. There's nothing really to factor and cancel. So how the heck do we solve this? Well, I plugged it into the calculator earlier, and as you can see, I got an answer of 2. But the question is, how did the calculator get an answer of 2? So that's what we're going to learn today. And we're going to learn this awesome rule called L'Hopital's rule. And L'Hopital's rule says the following. I'll let you read through this. So basically what you need that's really important is that when you plug in the value that x is approaching, and you have to get 0 over 0 or positive negative infinity over positive negative infinity. And what you can do is you can take the derivative of the original limit. So you take the derivative of the numerator and you take the derivative of the denominator, and then you plug in that value again for your limit and test it out. So I want to point out that this equation that I circled is not the quotient rule. So what we need to do is take the derivatives separately. And by the derivative separately, I mean take the derivative of the numerator separate from the derivative of the denominator. All right, so with that in mind, let's do D again. So it's the limit as x approaches 0 of e to the 2x minus 1 over x. And we already saw that it equals 0 over 0, indeterminate form. So we know that L'Hopital's applies. All right, and if L'Hopital's applies, that means that we can take the derivative of the numerator, which is e to the u times the derivative of u, or 2e to the 2x, over the derivative of the denominator, which is 1. And now we can plug in that value as x approaches 0 again. So we get 2e to the 0th over 1. As we said before, e to the 0th is equal to 1. And this is 2 over 1, or 2. And we can see how the calculator got 2. As I move to the second page, we're going to do several problems now that are examples of L'Hopital's rule. So for this first problem, again, the first thing we're going to do is, actually, I'm going to distribute so that it looks a little bit nicer. So I'm going to say the limit as x approaches 4 of 3x minus 12 over x squared minus 16. And that'll just be easier when we take the derivative when it's in that form. So if we plug in 4, we get 0 on top and we get 0 on the bottom. So we have the indeterminate form. And we can say that L'Hopital's, spelled L'Hopital wrong. We can say L'Hopital's applies. Okay, so again, we take the derivative of the numerator, which is just 3, over the derivative of the denominator, which is 2x. Plug in the value of x as it goes to 4, and we get 3 over 8. Boom, we've got our limit. Isn't that nice? Isn't that so much better than what we did before when we were doing this? For part B. Let's see, when I plug in 1, I get the natural log of 1 over 1 minus 1. Well, the natural log of 1 we know is 0 over 0. Sweet. L'Hopital's applies. You always want to make sure that you say that because you need to show that you do, in fact, get the indeterminate form. So because L'Hopital's applies, again, we can take the derivative, the numerator, and that is 1 over u times the derivative of u. Let me write that a little nicer. Derivative of u, all over 2x. All right, plug in 1, we get 1 over 1 times 3 over 2, and our answer is 3 halves. Sweet. All right, looking at the next problem. Plug in 1, we get 1 minus 1 over 1 minus 1, 0 over 0. L'Hopital's applies. And like we did in the last few problems, the limit as x approaches 1 of 11x to the 10th over 4x cubed. We plug in 1, we get 11 over 4, and we've got our answer. So these last 4 problems that I have for us, for A, same situation, we're going to plug in infinity. So the natural log of infinity, you should know that the natural log graph is constantly increasing. So the natural log of infinity would be infinity, and then x is infinity. So we have infinity over infinity. This is a situation where L'Hopital's applies again. So we're going to take the derivative. The derivative of natural log of x is 1 over x. The derivative of x is 1. And we get 1 over infinity over 1. 1 over infinity, so 1 over a supermassive number, is going to be really close to 0. And our limit is just equal to 0. All right, looking at B, we get infinity on top, because negative infinity squared is positive infinity, e to the negative infinity. So that's e to the positive infinity. The e to the x is a increasing function as well. It's an exponential function. So that would be infinity over infinity. And once again, L'Hopital's applies. So taking the derivative, we get the limit as x approaches negative infinity of 2x over, we have e to the u times the derivative of u. So negative e to the negative x. Let's try this again. We plug in negative infinity, and 2 times negative infinity is negative infinity. And e to the negative infinity gives us e to the infinity, or just infinity, times -1 is negative infinity. So we didn't get an answer after that first derivative, but the cool thing about L'Hopital's is that it still applies. Right? We can do it again. We can do it as many times as we need to get our answer. So we get the limit as x approaches negative infinity of 2 over e to the u times the derivative of u. So this changes it back to positive e to the negative x. And we get 2 over infinity. 2 over a massive number is just equal to 0. And the last two problems. We can rewrite this so that it is the limit as x approaches infinity of the square root of x over e to the positive x. Let's see, the square root of infinity, once again, is equal to infinity. And e to the infinity is equal to infinity. So, lucky for us, L'Hopital's applies again. So we're going to take the derivative, the limit as x approaches infinity. The derivative of the square root of x is 1/2 x to the -1/2, or 1/2 square root of x, over the derivative of e to x is just e to the x. And we get 1 over infinity over infinity. Let's see, 1 over infinity we know is 0 over infinity. 0 divided by anything is 0. So once again we have, excuse me, once again we have that limit equal to 0. And then last but not least, let's look at D. The limit as x approaches infinity, we'll rewrite it so that it's a fraction. X cubed over e to the -2x. When we plug in infinity, infinity cubed is infinity. E to the negative infinity. E to the negative infinity. Well, I know e to the x looks like this. So as I go to negative infinity, e to the negative infinity is actually equal to 0. So guess what? L'Hopital's does not apply. You might be wondering, well, then how do we know what our limit is? Fear not. We can merely just plug in infinity from the start. X to the infinity is infinity. E to the infinity is infinity. Infinity times infinity is infinity. So our limit for this one is just infinity. L'Hopital's did not apply in that one, but it did apply in all the others. Okay, that's what I've got to share. I'm going to post, excuse me, I'm going to post which homework assignments or which homework numbers I want you to look at over break. Yeah, thanks for watching, and look at that study sheet that I gave you. Have a wonderful, wonderful spring break. See you all on Monday, next Monday.